shape of the container, all that good stuff. So to start with, I guess we need to talk a little bit about our definition of pressure again. What's pressure?
Pounds per square inch or newtons per meter squared.
Which in terms of formula, that would be
Force over
I know it's force equals AP.
force over area, right? So pressure is force over area. Other thing we want to talk about with the fluid is, since we don't generally know its shape all the time and how much we're going to have, we need to talk about density, right? Which they tend to use. Well, that symbol is used some in other books. Our books and the AP tests tend to use that symbol. You know, the other one at least look more like a D. The rho, which looks like a P, but it's not pressure because it's a rho. Right, so you got to be careful here. Pressure is our capital P, right?
Rowing your boat.
So you're going to have to be really careful on how you write your, I guess, watch your P's and Q's, right?
What's
So
ours?
be careful. Your density, what's density again?
Mass over volume.
Mass over volume, right? So capital V, not to be confused with velocity.
Or voltage.
Oh, or voltage. We got to be nice and careful with our variables this chapter, right? Because don't worry, there are velocity in this chapter as well. So it gets a little tricky. All right. So the first thing we want to talk about is pressure, or absolute pressure. So absolute pressure. Well, that's basically all the pressure to be measured, right? So, measured. 2 S's in measure, 1 S is measured. Measured, there's an A in there.
There's one S.
There we go. Now it's missing one. The absolute pressure is all the pressure to be measured. So defining the two, gauge pressure. Oh, you got a flat tire or your balloon went flat. What's the pressure inside your balloon?
How much flat?
Zero. Zero gauge pressure, right? Because everything has got atmospheric pressure in it here that we're measuring on Earth, right? So gauge pressure is counting atmospheric pressure as 0. Right? So when we inflate a basketball, and it says, hey, inflate to 7 to 9 pounds. Hopefully that 7 to 9 pounds is pounds per square inch. So, boy, really non-scientific the way we deal with things, right? 7 to 9 pounds. It's a lot of pressure. So what are they talking about, right? It should be pounds per square inch. So again, our English system, we're not always so scientific with it. But atmospheric pressure is 14.7 pounds per square inch. So does that mean we negative? No, we're just counting 14.7 as 0 and 7 to 9 above that, right? So that's the whole idea. So if you kind of have to think about the two, is our absolute pressure equals our gauge pressure plus atmospheric pressure, right? Which our atmospheric pressure again is, what was it?
101,300.
Right? Kilopascals, right? So SI, our unit of pressure, is a pascal. So hopefully from all that thermo chapter, that should still be in there. And in our English American units, right, that is 14.7 pounds per square inch. Right? Pounds per square. Scientific unit versus our abbreviation unit of PSI. how are we going to measure the pressure of a liquid? What's the pressure of a liquid? So, let's think about pressure under a liquid. So we got our swimming pool, and let's say we're a certain height, deep. What was that? Certain depth. Funny though that we tend to in physics not really, we say depth, but we measure it as height up from the bottom, like how much water is above you. So be careful when they use those terms, that we still tend to use H a lot. So say this is water. Water. What's the density of water? 0?
It's one.
It's 1 what?
No.
One density.
One density unit. So in chemistry it was 1, right?
Yeah.
Wow, what's the units?
Kilogram per square.
Kilopascal.
Oh.
Squared centimeter.
Oh, kilogram per liter.
Kilogram per meter squared.
In physics, we should be doing kilogram per cubic meter, right? What'd you do in chemistry, though?
Liter.
The density of 1 was grams per cubic centimeter.
Oh, yeah.
Oh, we need it in kilograms per cubic meter. 1,000 kilograms per meter cubed. Okay. It is one gram per centimeter cubed. Right? There's 1,000 grams in a kilogram, but there are 1,000,000 cubic centimeters in a cubic meter. Right? So that's your factor of 1,000. So let's say we're under the water 3 meters deep. So let's find the gauge pressure under 3 meters of water. So you swim 3 meters down in the pool, that's 12 feet. I think you can feel that. Yeah, thanks. I guess that's 9.
That's 7.
Actually, 10 feet. If you're really looking at minor numbers. 10-foot basketball hoop is 3.05 meters, so almost 10 feet. How are we going to find the pressure? In other words, when we look at the bottom of the pool, we want to know how much force is going down on that amount of water. In other words, we want to know how much does all that water weigh? Right? Because the force pulling down on the bottom of the pool there, that was the bottom of the pool, 3 meters deep, would be the weight of all that water above it. Well, not the weight of all the water, just the weight of the water directly above it, right? We could either take the whole area of the pool, or we could take just 1 square meter of the pool. And either way, we're going to figure out how much water is above that. So what would the pressure be? That would be the force pulling down on all that area. What's the force of all that water? mg, right? Okay. How can we figure out the mass?
You know the density of the water.
Oh, mass, all right, good substitution. Mass is density times volume.
Thanks.
We need to get used to that. That's something we're going to use all the time during fluids. And we use it a lot. So get used to that substitution. So we always don't know how much of it we're going to have. That's how we're going to calculate the mass. So density times volume. So you just put it over there, right? So substitute that in. That becomes rho v volume times G over A. What's volume over area?
Just
Yeah,
one,
just
one filling.
Oh, age.
Height.
Makes sense?
Height.
Oh, yeah.
Is that right? Define the area of volume of a cube. It's length times width times height. Oh, area is length times width. Right? The area cancels out part of the volume, and you just get rho g h. So let's write it down here and box it out. Cool. So kind of looks familiar. It sounds like mgh. But rho is not really m, it's really the mass per area, right? Sure. Under gauge pressure, under 3 meters of water. So just to get a few numbers, right, our pressure is 1,000 kilograms per meter cubed times 9.8 times 3 meters. Is that right? Gauge. Not too bad. Part B. Can we find the absolute pressure under 3 meters of water? What would that be?
You just add.
Yeah, right? So my absolute pressure is just going to be the 29,400 pascals plus 101 300,000 pascals, right? Or 30.7 kPa. All right, jumping back and forth between kilo and regular. Cool. Just to get a sense of depth of water pressure, how deep underwater is the gauge pressure
Or C.
No.
sure equal to atmospheric pressure? In other words, that our absolute pressure equals 2 times atmospheric pressure, right? Does that make sense? What's that?
Isn't it like 38 feet?
Close.